Good morning everyone. See here. Now today in this live lecture we shall study a special condition of Euler equation, and we have to solve the problems based on special condition of Euler equation. See this. Up till in this unit second we have discussed the functional, linear functional, extremum of functional, fundamental lemma of calculus, Euler equation, problems based on Euler equations. Now today we shall discuss the special case, that is the variational functional also, a special case of Euler equation and the variation of the functional. See this, and we shall discuss the problems based on this. Now up till we have studied, this is the Euler equation for the extremum for the given functional j of y of x is equals to integral from a to b f of x comma y dash dx. If the functional is like j of y of x, then its extremum value given by the f suffix y minus d by dx of f y dash, which is equals to 0. The form of a general functional or curve is in this way. Now we have discussed these notes already. This is the fundamental lemma of a calculus of a variation. So today we shall move towards the special case of Euler equation. Now see this, 1 minute. Special condition of Euler equation. काल जे स्टुडंट्स लास्टला जो प्रॉब्लेम होता पहा, सौरभ वाडे कितव्या नंबरचा प्रॉब्लेम होता रे तो? मला थोडं तो प्रॉब्लेम नंबर सांग, मी करेक्शन सांगतो. स्पेशल कंडिशन for Euler equation. Special condition for Euler equation. See this. 4 नंबरचा, ठीक आहे. पहा रे, प्रॉब्लेम नंबर जो 4 आहे, त्या प्रॉब्लेम नंबर 4 मध्ये जो C1 कॅल्क्युलेट करतो. yesterday we have seen the problem number 4. I have given one problem number 4 for the homework. In that homework you have to take the value y of pi is equals to 1. कसं घ्या? You have to take the value y of, that is y of 0 is equals to 0. This is the first value, and y of pi is equals to 1 घ्या. In place of pi by 2 you have to take pi. आपण pi by 2 दिलं होतं, तिथं pi घ्या, नाहीतर C2 आपल्याला कॅल्क्युलेट नाही करता येत, नॉन डिफाइन येतो. So you have to take the problem number 4, you have to take the value y of pi is equals to 1, then you will get the definite answer. Okay. Now special condition of the Euler equation. What is that special condition? If f is, see here, what is that special condition? Case first. If f is, f means the functional is independent on y. If f is independent on of y, this is the special case. We know that the functional is given by j of y of x we can write the general form of a functional j of y of x is equals to integral from a to b, integral from a to b f of x comma y dash dx. Suppose this is a representation of a general function, functional. Here in this case the given function is a function of x comma y dash. Now we have to discuss here the special case of Euler's equation. In that case, first, in that special condition, f is independent of y. So if the functional is, if the function is independent of y, so then the form of a functional will be, so j of y of x is equals to integral from a to b f of x comma y dash only, because this is the general functional. If a functional is, or given function is independent of y, so y term will be absent, then our functional will be j of y of x is equals to integral from a to b f of x comma y dash. That means here f does not contain y. So here f does not contains the term y. So x is independent of y, therefore x is independent of y. So we can write, so our functional becomes, आता आपला functional कसा येऊ शकतो पहा, या ठिकाणी जो functional आहे f of x comma y, then we get the value of f of x which is independent of y. So we can write dou f by f suffix y or dou f by dou y, which is equals to f suffix y, which will be 0. याच्यामध्ये y ची टर्मच absent है, यहाँ पे देखो इसमें इस फंक्शन में y is absent, so there is no any term of y, that means y is independent of x, so its partial derivative with respect to x, with respect to y of that function will be 0 because there is no any term of y. So therefore the Euler's equation becomes what is the actually Euler equation? काय रे student सांगा बरं आंसर द्या. What is the Euler equation? So we know that the Euler equation Fy minus d by dx of Fy dash which is equals to 0, but we know that Fy is a constant 0, so we can write it will be 0 minus d by dx of Fy dash which is equals to 0. So d by dx of Fy dash is equals to 0. if the derivative of any term is 0, then we definitely say that that term will be constant. Then definitely we can say that that term will be constant. So we can write, therefore f(y dash), f suffix y dash, which will be constant, where we can write C is constant. C is constant. So this is the first order differential equation. So this is the first order differential equation which does not contain Now if we solve this equation, so if we solve this equation, suppose 2, now do 2, 4. If we solve this equation 4, then we get a function, which is a form of x comma c. So okay, तो फंक्शन असेल आणि तो कसा असेल, that is in the form y dash equals to f of x comma c, that is y dash equals to f of x comma c, and the solution of this curve the solution of this differential equation 5 is the curve having extremum value. हा जो differential equation है, see this, if we simplified this, then we get the differential equation of the form dy by dx is equals to f of x comma c, and if we solve this differential equation, then we get the curve which satisfies the extremum condition. काय म्हणता रे, f डबल डॅश, ओके. हा, सर्वांचं असं म्हणणं आहे का, ओम मिटकरी, क्रांती सूर्यवंशी, ओके, आय शॅल मूव टुवर्ड्स दिस. f डबल डॅश असं नाही आहे, f डबल डॅश ऑफ, इथं पहा डबल डॅश होत नाही, f डबल डॅश नाही होणार, f डबल डॅश होणार नाही. का तर रूल लक्षात घ्या, डेरिव्हेटिव्ह ऑफ सपोज एखाद्या कॉन्स्टंट टर्मचा डेरिव्हेटिव्ह जर घेतला, समजा डी बाय dx ऑफ कॉन्स्टंट k विच इज इक्वल्स टू 0, कॉन्स्टंट k इज इक्वल्स टू 0 असेल, एखाद्या टर्मचा डेरिव्हेटिव्ह जर 0 असेल तर ती टर्म कशी असायला पाहिजे, कॉन्स्टंट असायला पाहिजे. इफ वी टेक द डेरिव्हेटिव्ह ऑफ f ऑफ x, सपोज डेरिव्हेटिव्ह कधी 0 येतो, एखाद्या टर्मचा डेरिव्हेटिव्ह कधी 0 येतो, समजा डेरिव्हेटिव्ह ऑफ f ऑफ a इज इक्वल्स टू 0, मग एफ ऑफ एचा जर डेरिव्हेटिव्ह 0 असेल, then definitely we can say that this implies that f of a is constant, and we consider this f of a is equals to c. We have used this concept here. इथं concept आपण ती वापरलेली आहे. If d by dx of f y dash which is equals to 0, म्हणजे derivative of any term is 0, then definitely we can say that f y dash is equals to c. डेरिव्हेटिव्ह हा 0 असतो, म्हणजेच याचा अर्थ f ऑफ a कसा असतो, कॉन्स्टंट असतो. तसं d by dx ऑफ f y dash जर 0 असेल तर f y dash इज कन्सिडर्ड एज अ कॉन्स्टंट c. ही कन्सेप्ट वापरलेली आहे. ओके, आता हा जर फंक्शन, हे जर इक्वेशन आपण सिम्प्लिफाईड फॉर्म मध्ये लिहिलं, सॉल्व्ड म्हणजे सिम्प्लिफाईड. इफ वी सिम्प्लिफाय, सॉल्व म्हणण्याच्या ऐवजी काय करू, सिम्प्लिफाय. इफ वी सिम्प्लिफाय दिस इक्वेशन 4, then we get a function x comma c that is in the form y dash is equals to f of x comma c, that is y dash is equals to f of x comma c. This is the first order differential equation in the form of x and c. After the solution of this first order differential equation, we will get a curve having the extreme condition. समजलं का रे तुम्हाला? ही कंडिशन आहे, हे समजायला पाहिजे तुम्हाला. ओके, सो नाउ वी शॅल मूव टुवर्ड्स द प्रॉब्लेम्स बेस्ड ऑन दिस. आता याच्यावरचे प्रॉब्लेम्स आपण सॉल्व करू. ओके, नाउ सॉल्व द प्रॉब्लेम्स, एक्झाम्पल्स और प्रॉब्लेम्स. Now we have to find out the curve which satisfies the functional. Suppose this is j of y of x is equals to integral from a to b x into y dash plus y dash square dx. आता इथं काही इनिशियल कंडिशन्स वगैरे दिलेल्या नाहीत. इनिशियल कंडिशन्स किंवा बाउंड्री कंडिशन्स दिलेल्या नाहीत, म्हणजे C1 C2 आपल्याला कॅल्क्युलेट नाही करता येत. ओके, so answer, given functional is j of y of x is equals to integral from a to b x y dash plus y dash square dx. Here f of x, आता याच्यात y ची टर्म नाही पहा. Here in this function y is absent. Here in this case, in this special case, y is absent. So f of xy dash which is equals to xy dash plus y dash square. So this implies that f suffix y is equals to 0 by taking the partial differential equation. Also f y dash equals to डेरिव्हेटिव्ह घ्या. काय येतो रे f y dash? सांगा बरं स्टुडंट्स, व्हॉट इज द व्हॅल्यू ऑफ f y dash डिफरन्शिएटिंग दिस गिवन फंक्शन. सपोज दिस इज 1, this is 2. If we differentiating partially with respect to y is absent, so it will be 0. Differentiating also fy dash means differentiating with respect to y dash. Then now you tell me what is the differentiation with respect to y dash. वर्षा ठाकूर, अमोल थावरे, वेळेवर जॉईन व्हायचं रे, मध्येच कधी येऊन जॉईन व्हायचं नाही. सो वी कॅन राईट x इंटू y dash चा डेरिव्हेटिव्ह विथ रिस्पेक्ट टू y dash is 1 plus 2y dash. So we get fy dash equals to 1 plus x plus 2y dash. Now we know that the Euler's condition, special case किंवा Euler equation वापरा, काही अडचण नाही. We have the Euler's equation. What is that? fy minus d by dx of fy dash which is equals to 0. 0 minus d by dx of x plus 2y dash which is equals to 0. आणि जर स्पेशल कंडिशन वापरला, डायरेक्ट हा जरी फॉर्म्युला वापरला तरी चालतो, fy dash is equals to c, हा जरी वापरला तरी चालतो, किंवा जनरल फॉर्म्युला वापरून तसा फॉर्म घेतला तरी चालतो. सो वी कॅन राईट d by dx of x plus 2y dash which is equals to 0. If the derivative of any term will be 0, then we can write x plus 2y dash which is equals to constant c. So we can write 2y dash equals to c minus x. So here c is a constant. किंवा इथं तुम्ही अशी सुद्धा वापरू शकता, or we can use the special condition fy dash equals to c, then we will get same relation. Euler's equation न वापरता Euler स्पेशल कंडिशन जरी वापरलं तरी काही अडचण नाही. सो मायनस येतो का? कुठं मायनस येतो रे? कुठं मायनस येतं? नाडे मोहिनी, बरोबर नाही का? हा डेरिवेटिव ऑफ f with respect to y is 0 because y is absent. Then derivative of y dash will be x into 1 plus 2y dash. Then fy dash is equals to x plus 2y dash. So Euler condition वापरा, fy minus d by dx of fy dash 0 minus d by dx of x plus 2y dash. कुठं मायनस म्हणतं रे? कुठं मायनस राहिला? मायनस न तर मल्टिप्लाय केलं ना, काय अडचण आहे? इथं मायनस न मल्टिप्लाय केलं. सो मायनस डी बाय डी एक्स ऑफ x plus 2y dash which is equals to 0. Now multiplying by minus on both side. दोन्ही साइडला मायनस न मल्टिप्लाय करा. सो d by dx of x plus 2y dash it will be 0. मायनस लिहायची काय गरज आहे? मायनस न मल्टिप्लाय केलं दोन्ही साइडला. So it will be positive. आणि मग so we can write this. So our equation b will becomes मायनस नाही राहत. कुठं राहतं? मायनस न मल्टिप्लाय केलं ना, मायनस न मल्टिप्लाय केल्यावर कशाला राहतं? सो इट विल बी y डॅश विच इज इक्वल्स टू c minus x divided by 2. This is the first order differential equation. According to the Euler's special case, we have seen that we will get the first order differential equation in the form of f and c. So this is the problem which belong to the Euler special condition, that is y term is absent, and if y term will be absent, then we get the first order differential equation in terms of f and c. Okay, so we consider this as a suppose 3. Now y is a function of x, so we can separate this, we can solve. बाय टेकिंग इंटिग्रेशन, याला असं सुद्धा लिहितात, तुम्हाला डीप मध्ये समजा म्हणून सांगतो. y डॅश मीन्स dy by dx is equals to c minus x divided by 2. We can take the variable separation, dy is equals to c minus x divided by 2 into dx. This is the complete variable separation. By integrating, so integration of dy is equals to integration of c minus x divided by 2 into dx. So dy च integration, it will be y, we can write c by 2 minus x by 2 into dx. So we can take the integration of c by 2 with respect to x. C by 2 is a constant term, keep this as it is, and integration of dx will be x minus integration of x is x square by 2, so we can write x square by 4 plus constant of integration c1, constant of integration c1. ओके, तर अशा पद्धतीनं हे कॉन्स्टंट ऑफ इंटिग्रेशन c1 येतं. समजलं का रे तुम्हाला? इज इट ओके? काय अडचण? हां, 2y डॅश. ओके, काय अडचण आहे का तुम्हाला? पहा, वी कॅन राईट c बाय 2 x बाय 2 1 बाय 2. एक्सचं इंटिग्रेशन x स्क्वेअर बाय 2 येतो, मीन्स x स्क्वेअर बाय 4 c बाय 2. सो दिस इज द रिक्वायर्ड. So we get the final curve. So we get y is equals to c by 2x minus x square by 4 plus c1. So this is the general solution. This is the required curve. This is the general solution of the differential equation. This is differential equation 4 है का 3, which is the required curve, which is the required curve. आता यामध्ये c1 आणि c च्या व्हॅल्यू आपण काढू शकत नाही, कारण यामध्ये c1 आणि c2 काढण्यासाठी कंडिशन्स दिलेल्या नाहीत, बाउंड्री कंडिशन्स दिलेल्या नाहीत, इनिशियल किंवा बाउंड्री कंडिशन दिलेले नाहीत. जर y ऑफ 0 इज इक्वल्स टू 0, y ऑफ 1 इज इक्वल्स टू 1 अशा टर्म्स जेव्हा दिलेल्या असतील ना, देन वी कॅन फाइंड द सोल्युशन. अशा वेळेस आपण सोल्युशन, पर्टिक्युलर सोल्युशन काढू शकतो, नाहीतर आपण पर्टिक्युलर सोल्युशन कॅल्क्युलेट करू शकत नाही. वी कॅन फाइंड द कर्व, वी कॅन फाइंड द कर्व. ओके, नाउ वी शॅल मूव टुवर्ड्स द सेकंड प्रॉब्लेम. सेकंड, j of y of x which is equals to integral from a to b दिलेला आहे. see this, integral from 0 to 2, integral from 0 to 2 y dash square divided by x cube dx, and having extremum conditions y of 0 is equals to 0, y of 2 is equals to 4. Okay, then we have to find out the solution. See this, given functional is j of y of x which is equals to integral from 0 to 2 y dash square divided by x cube dx, having and y of 0 is equals to 0, y of 2 is equals to 4. Suppose this is 1. Here f of x comma y dash, here the function, in that functional, the function includes only x and y dash, y term is absent, therefore the given function is independent of y. So we can write y dash square divided by x cube. Now we can take, now here, therefore fy is equals to 0. Also fy dash which is equals to, सांगा बरे काय येतं fy dash, what is the value of fy dash? We have to take differentiation with respect to y dash. Differentiation with respect to y dash काय येईल सांगा रे? Derivative सांगा students. Y dash square divided by x cube. So if we differentiate with respect to y dash square upon x cube, so keep this x cube as it is. Derivative of y dash square is 2y dash. So 2y dash divided by x cube as it is. This is the Euler. Now by the special condition of Euler equation, direct मी इथं स्पेशल कंडिशन वापरतो, y dash which is equals to c. Okay, very good. राजमाने अनिता, वैभवी पवार, गीतांजलि शिंदे, पूजा माने, भाग्यश्री देवके, very good. So 2y dash divided by x cube which is equals to c. So 2y dash equals to c into x cube. So y dash equals to c into c by 2 into x cube. So our differential equation, this is equation number, we can consider suppose 2. Then we get first order differential equation in terms of x and c. And you know that according to the Euler condition, if a given function is independent of y, then Euler's special condition tells us that the partial derivative of f with respect to y dash is always constant c. That is, we will get the differential equation which is in the form of f of c. In this way we get the differential equation in the form of x and c. Now we have to solve this differential equation. Therefore y dash can be written as dy by dx which is equals to c by 2 into x cube. So separate this variable, dy is equals to c by 2 into x cube into dx by integrating. So integration of dy which is equals to c by 2 is a constant term, integration of x cube dx. चला रे स्टुडंट्स, नाउ यू टेल मी, थांबा बरं, आन्सर कोण कोण देत आहे त्याचा स्क्रीनशॉट घेतो. What is the solution of this integral? One minute. Now we can take the solution of this integral. Now you tell me the solution of integral of this function. Integral of dy is y which is equals to c by 2i. It is, now you have to calculate the value of integral. What is the value of integral? x cube च integral काय येतं? Now you tell me the, पाहतो मी, c कसं येतं रे, c कसं येतं, काय c काय सांगता तुम्ही? ओके, इंटिग्रल सांगा, इंटिग्रल. व्हॉट इज द इंटिग्रेशन ऑफ एक्स क्यूब? Now tell me, the integration of x cube is x raised to, okay, very good, x raised to 4 by 4. काही आन्सर कशाला देता, जे विचारलं ते सांगा ना, दुसरंच आन्सर सांगता तुम्ही. सो प्लस कॉन्स्टंट ऑफ इंटिग्रल सी, सो y इज इक्वल्स टू c into x raised to 4 by 8 plus constant of integral c1. C1 is a constant of integral. Here in this case we have to write the constant of constant of integral C1. Okay, now we consider this as equation number 3. Actually this is a general solution of the differential equation 2. This is the differential equation and this is the equation 3 is the general solution of differential equation 2 because it includes two arbitrary constants c and c1. So to find the values of these arbitrary constants, we have given the boundary condition or extremum condition, given that y of 0 is equals to 0 and y of 2 is equals to 4. Now from equation 3 we can write y of x is equals to c into x raised to 4 by 8 plus c1. So put x is equals to 0, therefore y of 0 is equals to c into 0 by 8 plus c1, but y of 0 is equals to 0 plus c1, so c1 will be 0. Also we can write y of 2, आता याची व्हॅल्यू y of 2 ठेवा, y of 2 is equals to c into 2 raised to 4 divided by 8 plus c1. Now see this. Now we have to calculate, we have to given the second boundary condition. I shall correct here. We have to second boundary condition, y of 2 is equals to 4. So put y is equals to 2 in equation 3. So we will get y of 2 means 4, which is equals to c into 16 by 8 plus c1 means 0. So it will be 4c is equals to 4 is equals to 2 into c. Very good. Therefore c will be 2. Put in 3. So y of x is equals to c into x raised to 4 by 8 plus c1. So y of x is equals to c means 2 into x raised to 4 by 8 plus 0. So y is equals to x raised to 4 by 4. बरोबर आहे का? आता पहा, this is the required curve which satisfies the given functional. Okay, and in this way we can obtain the solution of the functional. See this, we can obtain the solution of given functional in the different kind, that is according to the boundary condition. If the boundary conditions are given, then we will get the particular solution. If boundary conditions are given, then we will get the particular solutions. If boundary conditions are not given, then we will write the general solution. ओके, तर ठीक आहे. अशा पद्धतीनं हा पार्ट आपला इथं संपतो. काही होमवर्क, सिंपल होमवर्क देतो तुम्हाला 2-3 होमवर्क घ्या. होमवर्क आणखी बरेचसे प्रॉब्लेम्स आहेत, याच्यावरचे आपण सॉल्व करू. जे ऑफ y of x equals to integral from a to b, this is the general form, x square into y dash plus 2y dash square dx. Second, j of y of x equals to integral from 0 to 1, we can write this as 5y dash square upon x square dx. Third, where y of 0 is equals to 0, y of 1 is equals to 2. Third, j of y of x is equals to, you can take integral from 0 to 2, 4x cube into y dash plus 3y dash square dx. Y of 0 is equals to 0, y of 1 is equals to 4. Okay, now you have to solve these problems for homework. आता वेगवेगळे आणखी काही प्रॉब्लेम्स आहेत, उद्याला आपण घेऊ म्हणे. all these problems are independent of y. So you have to use the special case of Euler's condition. Okay, सॉल्व करताना स्टूडेंट्स सॉल्व कराल का रे? Okay, now we shall stop here. ज्या विद्यार्थ्यांना व्यवस्थित सॉल्व करता येतं, जे विद्यार्थी प्रॉम्प्ट आहेत, त्यांनी सर्वात अगोदर सॉल्व करून ग्रुपवर टाकत चला. म्हणजे काय होतं, बाकीच्या विद्यार्थ्यांना पाहून तरी करता येतं. बाकीचे विद्यार्थी पाहून होमवर्क करू शकतात. म्हणून ज्यांना जमतं, ज्यांना हे परफेक्ट येतं, त्यांनी अगोदर सॉल्व करून ग्रुपवर टाकत चला. ओके, ठीक आहे, थांबतो मग या ठिकाणी.